Okay, so today we're going to look at verifying trig identities. Okay, so let's say, for example, we had to simplify secant squared theta times 1 minus cosine squared of theta. Okay. This is just going back to all of those definitions we had earlier. Okay, so if you remember, you have sine squared plus cosine squared equals 1. Okay, and from that, you can get, if you subtract sine squared from both sides, oh, let me put that underneath it since I'm running out of room. You can get cosine squared theta equals 1 minus sine squared. Or if you subtract cosine from both sides, you have sine squared theta equals 1 minus cosine squared theta. Okay. We also know that for secant theta equals 1 over cosine. So that means that secant squared is equal to 1 over cosine squared. Okay. So we take what we started with and just replace it with what we have. So 1 minus cosine squared, we can replace that with sine squared of theta. Okay, so that means secant squared of theta times 1 minus cosine squared of theta will actually become, your secant squared is 1 over cosine squared. Times your 1 minus cosine squared, you can replace that with sine squared. Which the sine squared, you can just put that right up front. So you can have that as sine squared over cosine squared. Which you know sine over cosine is just theta, so sine squared over cosine squared, I mean not theta, tangent, sorry about that, is tangent squared. Okay, and that would be your final answer. Okay, so any questions on that one? All right. Go to another example. Right. Okay, so let's say, for example, if we wanted to simplify secant squared of theta minus 1 over secant squared of theta. Okay, so actually there are a couple of ways you can do this one. I'll show you both ways, well, two of the ways you can do this one. Pretty sure there are more out there I just didn't think of yet. Okay, so the first method, remember you have sine squared plus cosine squared equals 1. So if we divide all of these by cosine squared, that gives us tangent squared plus anything divided by itself here is just 1. And 1 over cosine is secant squared. So if we subtract 1 from both sides, that gives us tangent squared equals secant squared minus 1. Okay. And also, our secant squared at the denominator, secant squared is equal to 1 over cosine squared. Okay, so we're going to use those two. Okay, so that means our secant squared of theta minus 1 over secant squared is just going to equal our secant squared minus 1 is our tangent squared. And our secant squared in the denominator is 1 over cosine squared. Okay, so if you remember, tangent squared is sine over cosine. Well, sine squared over cosine squared. Okay, so that means, just continue that right here. You have tangent squared, so sine squared over cosine squared divided by 1 over cosine squared. Then you just go back to your rules for dividing fractions. You write down your first fraction. Your division changes to multiplication. Then you flip your second fraction. Okay, so now your cosine squared actually cancels out. Okay, so you end up with sine squared of theta. Okay, so any questions on that one? Now the second method is a little bit faster, but you have to actually notice it. Actually, let me put first method up here. Okay, so we have secant squared minus 1 over secant squared. Okay. If we wanted to, we could just separate these into two separate fractions. So you have secant squared over secant squared minus 1 over secant squared. Okay, anything divided by itself is just 1. So you have 1 minus 1 over secant is cosine squared. Okay. And if you remember, and I'll put that little side note here on over here. Sine squared plus cosine squared equals 1. So that means cosine squared equals 1 minus sine squared. Okay. Oh, sorry, should have switched those over. It should be sine squared equals 1 minus cosine squared. Yeah, it's a little bit messy looking. Okay, so sine squared of theta equals 1 minus cosine squared of theta. So this just becomes sine squared theta. So there's always more than one way to get the answer. Well, not always, but usually. All right, so any questions on that one? All right. Okay, so let's say, for example, we wanted to simplify. Clean that up a little bit. Sine squared of theta over 1 plus cosine of theta. Okay. Now with this one, the best thing to do is just remember the notation. Okay. So sine squared of theta, that's the same as saying sine of theta squared. Okay. Same thing with cosine. Cosine squared of theta is the same as saying cosine of theta squared. Just different notation. Okay. So we know that sine squared of theta is equal to 1 minus cosine squared of theta, which if you wanted to change to that, you could. That's 1 minus cosine theta squared. Or you can say 1 squared minus cosine theta squared, which if you notice is a difference of squares. Okay. So that equals 1 minus cosine and 1 plus cosine. So 1 minus cosine, actually, let me see if I can move that underneath it, since I'm running out of space there. Okay. So that equals 1 minus cosine of theta times 1 plus cosine of theta. Okay, so we can take what we started with, which was sine squared of theta over 1 plus cosine of theta. And we know that's equal to 1 minus cosine, separate that a little bit, squared of theta over 1 plus cosine of theta, which we figured out, the numerator was the difference of squares. So now these two cancel out. And you're left with 1 minus cosine of theta. All right. So any questions on that one? Okay. Now, a lot of times, if you want to, because there are a lot of times when you may look at this and not know exactly how to get started, remember that y equals sine of theta, x equals cosine of theta. So if you wanted to, you could have that y squared equals sine squared, or x squared equals cosine squared. Okay. And we also know that x squared plus y squared equals 1 on the unit circle. Okay. So the reason I brought all of that up is because if you wanted to, you can replace your sines and cosines with x's and y's. So to kind of point it out a little bit, where it looks a little more familiar. So you can have sine squared over 1 plus cosine of theta. If you wanted to, you can make that y squared. Oh, let me separate that a little bit. Over 1 plus x. Okay. So we know that y squared is 1 minus x squared. Over 1 plus x. Okay. So sometimes that may look a little familiar, where it's a little easier than trying to figure out what to do with all these sines and cosines. Okay, so if you made this 1 plus x times 1 minus x over 1 plus x, you'll see just like it did up here, it cancels out. So you're left with 1 minus x, which is just 1 minus cosine. So it's just another method to get the same answer. All right, so any questions on that one? All right. To get the same answer. Here we go. All right, so let's say for our next example, we want to simplify tangent of theta times secant theta minus 1 times secant of theta plus 1. So this one's somewhat similar to the previous one. Is that our difference of squares, which is a squared minus b squared equals a plus b times a minus b. And it works the other way if you just FOIL it. So all we have to do for these two, if you notice, is secant minus 1 and secant plus 1, which is really the same form as our difference of squares. So that means our tangent of theta, of secant theta minus 1 and secant theta plus 1, if we just FOIL these two, we end up with tangent of theta times secant squared. Your outer is plus secant theta and minus secant theta, so those two cancel out. And your last is minus 1. Okay. Now we also know that tangent squared plus 1 secant squared, which means that tangent squared is secant squared minus 1. So all we have to do is plug in our tangent here. So you have tangent theta times tangent squared of theta. And you just combine those and you get tangent to the third of theta. So sometimes it's just about recognizing a formula that you've used before. All right. So any questions on that one? All right. Okay, so from there, we're going to go to our addition and subtraction formulas. Okay, so for sine, let's say you have sine of a plus b. That's going to equal sine of a times cosine of b plus sine of b times cosine of a. Same thing with subtraction. Sine of a minus b is equal to sine of a cosine of b minus sine of b times cosine of a. Okay. Now for cosine, it's a little bit different. If you have cosine of a plus b, that's equal to cosine of a times cosine of b minus sine of a times sine of b. Okay, so for cosine, the signs actually will switch. And cosine of a minus b is cosine of a times cosine of b plus sine of a times sine of b. Remember, I always tell you I'm the king of bad memories, so I have a little bit of a shortcut to help you remember these two. If you notice, the a and b switch for these two. If you notice sine, psycho. Sine, cosine, sine, cosine. So that's my little hint for that one. For cosine, I have that as cocoa. Cosine, cosine, and the other one's sine and sine. The only thing about cosine is you have to remember that the plus sign changes to minus and the minus sign changes to plus. Like I said, just one of those little things that help me remember. Okay. Now for tangent, you have tangent of a plus b equals tangent of a plus tangent of b divided by 1 minus tangent of a times tangent of b. Okay. With that one, it's pretty much one of those, the plus sign is plus sign here, so here it's added, there it's multiplied. And then when you subtract, that turns to minus, and that becomes plus. Okay. So this sign is going to match the numerator. So tangent of a minus b is going to equal tangent of a minus tangent of b all over 1 plus tangent of a times tangent of b. See if I can get all of them on there. Okay. So those are your adding and subtracting formulas. Okay. Okay, so let's say, for example, let's say if you're given that cosine of A is equal to negative 5 over 13, and sine of B is equal to 7 over 25. And they want you to find cosine of A plus B in quadrant 2. Okay, so both of those are in quadrant 2. Okay. Now when you have a problem like this where you have a cosine of A, sine of B, or sine of A, cosine of B, your first step is to draw your two right triangles. And, well, in this case, quadrant 2. Okay, so we have our triangle here in quadrant 2. You have your X, you have your Y. Your triangle here, do the same thing in quadrant 2. Okay, so this one, we're going to have this as our cosine of A, which means our A, which is usually our theta, is right there. And you can draw your right angle symbol there. And this one, we're going to have this one for our sine of B, where instead of theta, we're just going to put our B right there. Okay, so we know that cosine is equal to adjacent over the hypotenuse. Which in this case is negative. Well, I'll put the negative in front. Negative 5 over 3. Oh, 13, sorry about that. Okay, so that means for our angle A, our adjacent is 5. Now you can put the negative if you want to. You don't have to right now, but sometimes you can put it there. But for me, normally I just keep it as positive because we're going to figure out whether it's positive or negative at the very end because of the quadrant. Okay, and our hypotenuse is 13. Okay, for sine of B, remember sine is opposite over hypotenuse. Okay, and we know from up here that it's 7 over 25. So our opposite is 7, and our hypotenuse is 25. Okay, so here we have a right triangle, which means we can use our a squared plus b squared equals c squared to solve for our missing side. So use Pythagorean theorem. A squared plus b squared equals c squared to solve for the missing sides. Okay. So for the sake of space, I actually did that already, and we ended up with 12 here. And for this one, we ended up with 24. And I'll circle those just to know we solved.